looking at polynomial inequalities. I want to graph this equation by hand and use it to solve the following inequalities. So first of all, I can use the techniques of the last section since this is a degree 3 and I can't easily do a factor by grouping. I can use the techniques of the last section to find possible rational zeros for this. So I take the factors of the constant term and divide by the factors of the leading term. So my constant term is 30, and that factors into 1, 2, 3, 5, 6, 10, 15. Did I miss anything there? I don't think so. I think that's all of our factors. And the leading term is a 1, which only has the factor of 1. So remember, it is the factors of this in the numerator divided by the factors of this. Well, the factors of 1 are just 1. So I'm basically just using plus or minus all of these numbers that I wrote down up here, testing them to see if I get a 0. And what we will see is that 3 should give us a 0. So let's see that. 3 through synthetic division will go 1, 4, negative 11, negative 30. Bring down the 1. 1 times 3 is 3, 7, 21, 10, 30, 0. Now remember, this that is left over is 1 degree left, so x squared plus 7x plus 10. And that factors into x plus 2 times x plus 5. So my polynomial here factors into the 1, 0 we found, x minus 3, times x plus 2, times x plus 5. So we have a 0 at positive 3, negative 2, negative 5. So drawing our graph, I have a 0 at negative 5, 1, 2, 3, 4, 5. And again at negative 2. And at positive 3. And if you plug in 0, 0, 0, 0, negative 30. So all the way down here at negative 30, I'll have a y-intercept. Now, the leading coefficient is positive, and the degree is odd. So remember, that means the right arm goes up and the left arm goes down. So this should look, cross the 0, there are a multiplicity of 1. Something like that by hand. Okay, so to solve where it equals 0, that's at negative 5, negative 2, and positive 3. To solve where it's greater than 0, I'm looking for where it's above the x-axis. That is this interval of numbers, so between negative 5 and negative 2. And again, past here. So that's from 3 to infinity. We're above the x-axis. Now to solve where we're less than or equal to 0, that's where we're below the x-axis. So less than negative 5 would be negative infinity to negative 5. This time I use a bracket because of the equal to. I want to include the endpoint. And then union with, notice it's below the x-axis on this interval. So that's between negative 2 and positive 3. So bracket negative 2 to bracket 3. And I want that to be, again, included because of the equal sign. So now, if I go to my graphing calculator and I graph this equation, I see my graph looks something like this, basically what we drew. And I can see that we're above the x-axis here and here, below the x-axis this way, and in between here. Now to find these zeros, you can use second and the trace key to bring up the calc menu. Option 2 is your 0. Give it a left bound, so I want to move until my cursor is blinking left of that first 0. And I see it over here. So enter. Now to the right of that first 0, enter. and then give it a guess to start approximating, and it tells me that that 0 is at -5, the first one that we found here. Repeat that process, second, calc, bound this next 0, and you can find the next 0 and so on. So you can use the graph to help you with that as well. But the main point is when it says bigger than like this, look for where it's above the x-axis, and here look for where it's below the x-axis.